Assalamualaikum. My name is Muhammad Azubir Ismail, and here our team will present about our project. Our project is AquaTrack Smart Safety Wristband System for the Water Park Presentation. And here our group project for the ICT 554. Okay, for this slide, show our proposal submission detail divided into the part A and the part B. For part A, our project title is AquaTrack Smart Safety Wristband System for the Water Park. The project leader is me, Muhammad Azubir Ismail, and the group member are Muhammad Aziz Amir, Muhammad Iqwan bin Khairuddin, and Muhammad Hassan bin Bahrain. We are from the class CS240-3A under University Teknologi Maga, Shah Alam, Faculty of Computer and Mathematical Science. Our supervisor is TS Mudiana binti Moksin or Miss Ron. Okay, for the part B, the research focus for
Hi, Assalamualaikum warahmatullahi wabarakatuh. So basically, our project AquaTrack is an IoT smart safety wristband system designed to enhance drowning prevention and emergency response in water parks. So basically, the system we use a waterproof wearable wristband equipped with heart rate monitoring, location tracking, and also a wireless communication. So all the data collected from visitors is also transmitted in real time to a cloud-based platform. So in our project, we use a web dashboard and mobile application which allowed every single lifeguard and operators to monitor every visitor status, receive automated emergency alerts, and also take an immediate action when abnormal conditions are detected. So by combining sensor technology, cloud processing, and also real-time data analytics, our project AquaTrack provides a comprehensive safety solutions. This system not only improve visitor protection but also reduce operational risk and supports modernization in recreational industry. Overall, AquaTrack demonstrates strong positive potential for commercial adoption by water parks, resorts, and aquatic facilities that aim to strengthen their facility safety through smart data-driven innovations. As for our background project, water park actually attracts a very large number of visitors every day, making them environments with high risk for drowning and water-related emergency. So currently, most water parks rely heavily on manual visual monitoring by lifeguards. However, this approach has its own limitations due to crowd density, environmental condition, and also human reaction time. As for the result, early sign of distress may go unnoticed, leading to delayed response and more severe incidents. In addition, most facilities do not have system capable of providing real-time heart rate or locating data for individual visitors. This makes it difficult to identify emergency quickly and accurately. With advancement in wearable IoT device and cloud-based monitoring system, new opportunity now exists to enhance aquatic safety. So basically, AquaTrack leverage these technologies by introducing a smart wristband that continuously monitoring visitors' heart rate and locations. Through automated alerts, live visualization, and data analytics, AquaTrack enhance situational awareness and support faster emergency intervention. This highlight the growing needs for digital data-driven safety tools to modernize water park operations. As for our project problem statement, despite the risks involved, water parks still depend mainly on lifeguard visual observation to monitor large crowds. Early signs of drowning or distress are often subtle and may be missed because there is no system to track visitors' heart rate and or location in real time. When an incident occurs, staff may also struggle to allocate the victim quickly, causing delay during critical moments, which this lack of a digital and automated safety system leads to slower response time and increase the risk of preventable accidents. The key issue identified includes delayed detection of drowning incidents, absence of real-time heart rate data, difficulty locating visitor during emergency, high dependency on manual human monitoring, lack of an integrated data-driven safety system. So basically, AquaTrack is proposed to address these challenges by enabling continuously monitoring real-time alerts and faster emergency detections. So for our objective of the research that we did, the main aim of this research is to develop and evaluate an IoT-based smart safety response system that enhance emergency detection, response, efficient, and overall visitor safety in water parks. To achieve this, several objectives are outlined in our project, which is to design and develop a smart wristband equipped with heart rate monitoring, GPS tracking, and IoT communication to create a cloud-based monitoring platform that visualize real-time heart rate and visitor location, to implement an automated alert mechanism that detect abnormal conditions such as a lower heart rate or prolonged inactivity, to evaluate the system effectiveness in improving emergency response time, to assess the usability and practicality of the system for lifeguards and operational staff. So basically, these are the objectives to ensure that AquaTrack is not only technically functional but also suitable for real-world water parks environment system. So for our literature review focus on the study of Jalil Lifar Saman et al. 2022, titled "A Smart Multi-Sensor Device to Detect Distress in Swimmers." So basically, the study highlights that traditional lifeguard monitoring alone is often insufficient, specifically in a crowded aquatic environments. So basically, the researcher developed a wearable multi-sensor device that tracks biometric and motion data to identify swimmers' distress. So their system use sensors such as heart rate motion and orientation detectors to detect unusual patterns like sudden immobility and irregular heart rates. When abnormal behavior is detected, alerts are sent to a monitoring system for timely intervention. So the study emphasized that sensor fusion improves detection accuracy compared to single sensor system. However, challenges such as waterproofing, sensor stability, and communication reliability were also identified. In conclusion, the researchers found that wearable multi-sensor device can significantly improve early detection of swimmer distress. This directly supports the concept of AquaTrack, which integrates real-time biometric monitoring system and automated alerts to enhance safety in water parks. So for our research methodology, we follow the product development lifecycle, or we can call it PLDC, which provide a structured approach to developing this AquaTrack project. So in PLDC, we have seven steps, which is the first one is identification, where the core problem of delayed drowning detection is identified, leading to the concept of a smart safety wristband. For the second part is research, which includes literature review and market analysis to understand the existence of the technology and the user needs. For the third part is a design, where system architecture, hardware component, and user interface are planned using diagram and wireframe. For the fourth part, which is the development part, where the wristband firmware and cloud backend, dashboard, and mobile application are built and integrated. For the fifth part, which is testing, focusing on heart rate accuracy, waterproof durability, connectivity stability, and alert performance. And for the sixth part, which is launch, where the system is prepared for pilot development and demonstration. And finally, post-launch involve collecting feedback to improve our project accuracy, usability, and scalability for the real world adaptation. So that's all for the research and methodology part.
Okay, next for project design or prototype. This slide shows the project design and prototype of AquaTrack. AquaTrack is a smart safety response system designed to monitor visitor safety in water park using real-time biometric and location data. Okay, from start down menu, first filter by zone. This feature allows operator to filter visitors based on specific water park zones such as the wave pool, kids area, slides, lazy river, and hot tubes. It helps lifeguards focus on a particular area instead of monitoring the entire water park at once. Second, filter by heart rate. This filter classifies visitors based on real-time heart rate data collected from the smart wristband. Visitors are grouped into normal, elevated, and high heart rate categories to help detect potential risk early. Okay, for normal, 60 to 100 bpm, elevated 101 to 130 bpm, high rate more than 130 bpm. Okay, for number 3, real-time visitor tracking, which is central map view. This feature displays a real-time visual map of the water park divided into multiple zones. Each visitor is represented by an icon that shows their current location and safety status based on a data received from the smart wristband. Green indicates normal status, orange indicates prolonged inactivity, and red indicates an emergency of possible drowning. This allows lifeguard to quickly identify at-risk visitor and respond immediately. Okay, number 4, Active Alerts Panel. The Active Alert Panel display emergency notifications such as abnormal heart rate alerts and possible drowning alerts. Lifeguard can analyze the alert, dispatch assistance, or mark the incident as resolved after action is taken. Number 5 is real-time pulse trend. This page displays of a graph of heart rate trends over time for a selected visitor. It helps lifeguard monitor sudden change in heart rate and supports better decision making during emergencies. Number 6, statistic panel. The statistic panel provides an overview of system and operational status. It shows the total number of visitors online, safety alert triggered today, active zone, system uptime, and IoT network connectivity. This helps operators monitor overall system performance in real time. Okay, number 7, search bar. The search bar allows operator to quickly find a visitor using their visitor ID, wristband number, or current location. This feature is especially useful during emergency situation. And the last thing, number 8, system setting and history log. System setting allow operators to configure heart rate threshold, manage zone and user, and adjust alert sensitivity. The history log record all alerts and action taken for auditing, reporting, and post-incident analysis. Okay, for smart wristband watch, the smart wristband is the core hardware component of the AquaTrack system. It is worn by visitors throughout their time in the water park and continuously collect biometric and location data. First, heart rate monitoring. The wristband continuously measures the visitor's heart rate using an integrated heart rate sensor. This data is used to detect abnormal conditions that may indicate danger. Second, location tracking. The wristband track the visitor's location within the water park using GPS, BLE, or zone-based positioning technology. This enables accurate location identification during emergencies. Okay, number 3, inactivity detection. The wristband detects prolonged inactivity by monitoring motion and heart rate data over a period of time. Prolonged inactivity in water may indicate a potential drowning risk. Number 4, real-time data transmission. All collected heart rate and location data is transmitted wisely to the edge gateway and cloud platform using IoT communication protocols. Number 5, waterproof and wearable design. The wristband is designed to be fully waterproof, lightweight, and comfortable for continuous wear in water environment. Number 6, unique visitor identification. Each wristband is assigned a unique ID that is linked to a specific visitor. They ensure accurate monitoring and alert generation without confusion. Last, number 7, emergency detection trigger. When abnormal heart rate, prolonged inactivity, or risk pattern are detected, the wristband contribute data that trigger an automatic emergency alert. This enables faster response without relying on manual observation. Okay, so AquaTrack integrate smart wristband, real-time monitoring, and automated alert to improve emergency detection and enhance visitor safety in water park environment. Okay, this slide shows the technical architecture diagram of the AquaTrack system and how all components work together. The process begins with the wristband device. The wristband is worn by visitors and it collects heart rate and location data. This data is sent wisely using Wi-Fi. Next, the data is received by the edge gateway. The gateway actually as a bridge between the wristband and the cloud, and it securely forward the data to the internet. After that, the data enters the cloud increase layer, which use MQTT or HTTPS. These layers checks the data, verifies it, and route it to the correct system component. Then the data is processed in the application layer. In this layer, the system analyzes heart rate and location information, detect possible emergencies, and generate alert when abnormal conditions are found. All process and historical data is stored in the database layer. This data can be used for record analysis and future planning. At the same time, the client interface such as the web dashboard and mobile application receive live update from the application layer. This allows lifeguard and staff to monitor visitor in real time. Finally, the monitoring and operation layer monitors system performance, manage update, and ensure that the entire system runs smoothly and reliably. Overall, this infrastructure is support real-time monitoring, fast alert delivery, and reliable operation at the AquaTrack system.
Hi, I'm Hassan, and for this part, I will explain the main challenges that we faced in developing and implementing the AquaTrack system. One of the primary challenges is the accuracy of biometric sensors. Since it is a wristband in use in the water environments, factors such as constant movement, water pressure, and inconsistent of skin contact may affect the heart rate readings. Another major challenge is that the wireless connectivity. Technologies like Wi-Fi and Bluetooth can experience signal interference around water, which may disrupt the real-time data transmission. In addition, battery life is a concern, as continuous monitoring and data transmission require efficient power management. There's also a risk of false and excessive alert if detection thresholds are not calibrated properly, which could lead to alarm fatigue among the lifeguards. Other challenges that I can say is that they include user acceptance, where visitors must be willing to wear the device, and staff readiness, where lifeguards need a proper training to interpret the system alerts. Finally, data privacy, security, and system scalability are critical as the system handles sensitive biometrics and location data, and also must support the large number of users reliably. Thank you. Okay, next, I will discuss the implications of this research and how it aligns with the Sustainable Development Goals. Uh, Firstly, the AquaTrack supports the SDG 3, the good health and well-being by reducing preventable drowning incidents and improving early emergency detection through the technology. Secondly, it aligns with the SDG 9 industry innovation and infrastructure as it promotes the use of smart IoT system, cloud computing, and modern safety infrastructure within the recreational industry. Lastly, the system contributes to the SDG 11, which is the sustainable city and the communities by improving the safety in public recreational spaces such as the water parks and aquatic centers. Okay, overall, AquaTrack encourages the policymakers and facility operators to adopt the preventive, data-driven safety solution instead of relying solely on the manual monitoring. Okay, next, moving on to the benefits for the community. For visitors, AquaTrack significantly improves safety through real-time monitoring and early detection of potential drowning incidents. It also provides the additional protection for vulnerable groups such as the children, elderly, individuals, and also non-swimmers. For lifeguards, the system provides instant alert and precise location information, allowing faster and more accurate rescue operations. This reduces the physical stress and cognitive workload during the emergencies. From a broader perspective, AquaTrack enhanced the public trust and tourism as safer recreational environments, encouraged more family and tourists to visit the water parks. Next, in terms of industrial benefits, water park operators gain safer operations, reduce liability, and also fewer the incidents-related risks. Management teams benefit from data-driven insights, which help in safety planning, staffing decisions, and compliance with safety regulations. Additionally, the system creates the opportunities for the IoT and technology industry, including system installation, maintenance upgrades, and long-term technical supports. This makes the AquaTrack not only a safety solution, but also a driver of digital transformation within the recreational industry. Next, I will explain the commercial value of AquaTrack system. From a business perspective, I can say that the AquaTrack helps water park operators reduce the accident-related risks and potential legal liabilities by enabling the early detection of emergency situations. This reduces the likelihood of severe incidents and costly consequences. The presence of a smart safety system also increases the visitor confidence and trust, especially among families with the children. When visitors feel safer, they are more likely to choose and revisit facilities that prioritize safety. In addition, I can say that the AquaTrack improve operational efficiency by providing real-time monitoring and automated alerts, allowing staff to respond faster and manage the safety more effectively. The system also generates valuable data insights, which support better management decisions and related to staffing, safety planning, and facility operations. Most importantly, AquaTrack is scalable and adaptable, meaning it can be implemented not only in water parks, but also in resorts, hotels, and aquatic centers, making it a commercially viable and sustainable safety solution. All right, thank you.
The novelty of this project is development of an integrated IoT-based safety system designed specifically for the water park. Unlike traditional methods that depend only on lifeguard visual monitoring, this system combines heart rate monitoring, location tracking, and automatically alert in a waterproof wearable device. By using real-time heart rate and location data, the system can detect early signs of distress that are not easily seen by human observation. In addition, the cloud-based system allows fast data processing and send alert to both the dashboard and mobile application. The system also provides zone-based visualization, which help lifeguards locate victims more quickly and accurately during emergency. Overall, this project introduced a proactive and data-driven approach to improve drowning prevention in water park environment. This screenshot shows the project timeline for the AquaTrack from October to January. In October, we focus on ideation and initiation research, where we identify the problem and study related work. In November, we continue the research and start system architecture and design. During the December, we focus on prototype development and system integration. In January, we carry out testing and evaluation, followed by project launch and demonstration. After that, we conduct post-launch review and improvement. Throughout the project period, proposal writing and final documentation are done continuously. This timeline ensures the project is completed in the structured and organized manner.